Thank you for joining us today on this presentation on FeatureOps and how we use Unleash to supercharge experimentation here at ASAP. Before we get into the meat of the presentation, I wanted to just give a quick introduction to who we are and what ASAP does. Hi, my name is Ivan. I'm a longtime contributor and maintainer of Unleash Python SDK. In my day job, I'm a principal platform engineer at ASAP. I'm joined here today with my coworker, Tommy, who's a lead machine learning engineer. We both work on the platform engineering team at ASAP, and we work at ASAP where we build Gen AI native customer service solutions for enterprise call centers. Now, platform engineering is one of those phrases that means a different thing for different companies. So in our case, we view platform engineering as really building the bridge between the development and infrastructure domains to make building features fast, easy, and fun. Unleash is a really important part of our toolbox. We're longtime users and very excited to speak to you all today about how we deploy, use, and experiment with Unleash. But just to give you an idea of why it's so important for ASAP, I wanted to give you a little bit of background information on ASAP and kind of our use case. Our architecture needs to support multiple enterprise-grade customers like Dish, JetBlue, and other Fortune 500 companies. And that means addressing some very complex operating environments. We have a microservice architecture. So one kind of big theme for us as a platform team is thinking through tool adoption. We have different products, right? We have some things that are human-facing applications. We have API as a service products, and it covers a variety of different channels, right? We deal with both like the chat prompts that show up when you talk to an agent, and we also deal with voice channels where people are calling into call centers. And we need very complex development models to fulfill customer data needs, right? We have some cases where companies want single tenant deployments, and we have two different flavors of multi-tenancy. So for example, we have a deployment-based multi-tenancy as well as logical multi-tenancy, where we kind of have controls that guarantee customer data separation. We believe really strongly in kind of continuous delivery and deployment. We've invested a lot in this area, and in this situation, kind of the full stack feature ops approach is really critical for us to safely deploy our code, our models, and our prompts. I wanted to give a quick kind of history of how ASAP discovered Unleash and how we got to where we are. So we discovered Unleash in 2017 when the project was still very much in its infancy. We were able to get a test instance running in like 3 or 4 days. The gentleman who did the work is still at ASAP and is currently running our data infrastructure. And we were able to do a quick POC shortly afterwards. That was very early in the life cycle. And our initial architecture was kind of to have a independent Unleash deployment for each of our Kubernetes clusters. This was way before progressive constraints existed, and this was kind of our way to be able to have a customer-specific feature flags deeply integrated into our technical stack before that was fully supported on the platform. But by 2019, we kind of found that the overhead of running Unleash services was a little too much. And one of the cool things was we were able to partner with Ivar and Unleash early in kind of the company's lifetime to build constraints that were a little bit more capable of handling multi-tenancy and handling multiple customers out of the same instance. We also made a really big push to standardize our frameworks, our base frameworks, and kind of make sure everyone was using Unleash in the same way. And we'll talk about that a little bit later in the presentation. So as ASAP's product offering began to mature, experimentation became a much bigger part of our product development strategy. Now, my last job was before ASAPP was at a B2C company where that sold a fitness app, and we did a lot of A/B testing. But we were really blessed by having a reasonable, sticky product and people who really wanted to use it. Now, if you think about call centers, it's a little bit of a different situation, right? Where the people using your app are very frequently call center employees with very high turnovers. So like the normal strategies you would use to kind of test user engagement are a little bit weird, right? And very often the people they're talking to, which are real customers, are often not in the best mood, right? I have personally called into call centers and to deal with things like phone bills, and it's not the best experience for everyone. So being able to show positive changes from both like new models or new UI UXs requires a lot of kind of parallel, like out of the box thinking, and a big focus on kind of the full stack experiment solution. When we were kind of putting together our experiment system, we tried very hard to kind of use what we had, right? We had a good front end metric system, so we didn't want to invent that wheel. And Unleash kind of was able to meet us where we were, right? We had used it for feature flags. And the really good news was that the experimentation and the ability to define different variants and was built into the feature flag offering, and it made it really easy to very quickly adopt across multiple programming languages, right? Not just we have different languages at ASAPP, but so it was able to kind of span the same code that did experiments was able to support our Go microservices in our middleware service, but also with the Python services and our backend services that were executing models. And the kind of the best thing, and I am a strong believer that experimentation is very data driven. And the cool thing about Unleash is that it has this built-in schema for recording the lifetime of events, and we were able to extract it and sort of merge it downstream into our data warehouse for our data scientists to analyze. One of the things kind of that we did at that point was we did build an internal experimentation system to kind of build a golden path for developers who wanted to start new A/B tests. And I think one of the things that has changed between that point and where we are today at ASAPP is that Unleash has really built out its model creation and promotion process on the cloud. And we're really excited. One of the things that we're really excited for right now is kind of figuring out how we can effect that migration to Unleash's cloud and use their tools to kind of supercharge our delivery, experimentation, and learning. So we're kind of in between sort of migrating our deployment to Unleash Cloud, but I did want to kind of talk a little bit about our internal deployment scheme. I think this is a really good reference architecture that helps us handle that complexity while the complexity of our deployment platform while hosting our own Unleash. So our feature flag architecture leverages Unleash to maintain releases across multiple Kubernetes architectures, right? So we have multiple clusters. We generally divide these into so-called environment types, like test, pre-prod, and prod. And each environment type has an Unleash instance supporting it. We use constraints to allow us to target customers across our different cluster architecture. So we have kind of standardized, hey, for our particular environment, how do we set up our how do we target a feature flag at a particular customer's deployment? If you are a developer, we kind of have tried to use some tooling to bridge the gap between provisioning and self-service. So if you are a developer, you make Unleash has really great APIs. One of the things we love with integrating them is they are very much an API first company. So we were able to use that to build a pretty cool process where developers kind of use a configuration repository to bootstrap the feature flag. We have scripts that seed and promote configuration across our different Unleash instances. And then a developer still gets the benefit of being able to go to our internal Unleash and say, like, I want to roll this feature out to 20%, 40%, 80%, 100%. And over time, we kind of get the both. We have a process that kind of reconciles that change down into lower environments. So we can ensure that we have a really great balance between developer agency and the ability to configure our feature flags versus keeping our feature flags up to date across all our environment for like testing and development purposes. So when we're talking about adoption, one of the biggest ways for us to drive that Unleashed adoption, both for feature flags and experiments, is through the concept of a base framework. So we found that base frameworks are critical for platform engineering and a microservice architecture, right? So we kind of view platform engineering as bridging that gap between kind of the infrastructure and how you consume that infrastructure. And it's really powerful when you're doing that, when you control both sides of that bridge. I'm not sure that's a great metaphor, but it really allows that platform engineering to control both types of the interface. So we work really closely with our developers on building these base frameworks. So for example, in this case, we are both maintaining Unleash and kind of defining how you're creating and using Unleash feature flags, but we're also controlling how Python services or Go services instantiate the Unleash client, set up the context, and call Unleash, right? When we do this work, we believe in working really closely with our developers on building these frameworks. We do our best to drive these as kind of an internal open source or inner source project where people are open to contribute. We have driven a lot of adoption by maintaining opinionated support for Unleash in our base frameworks for things in Go, Python, and TypeScript. This allows us to do things like do smooth configuration and bootstrapping, like defining common patterns so that everyone it makes it super easy to connect to Unleash with the right credentials. It helps us guarantee good reliability patterns. Unleash has a lot of built-in resiliency that we want to make sure we're making the best use of, and doing it at one place is always easier than doing it at a lot of places. Standardizing contexts. So common identifiers are automatically passed into feature flag context has also helped us a lot, right? So we standardized our context to pass in things like tenant ID and agent IDs, so that developers will always have those things available, and it makes it easier for people to set up feature flags. We found that in particular was really helpful. It kind of takes as much thinking out of, like, it requires the developers to do less thinking to get the most out of the feature flags they're provisioning. And we did want to give a special shout out, like having SDKs that could bridge multiple languages and design paradigms, right? Both front end and back end languages or frameworks has been really amazing. And I think Alicia's recent work with Yggdrasil, to standardize the logic even further, has made it both more reliable and awesome. Cool.
So, talking about the different frameworks present at ASAPP, for Python in particular, teams usually need to be able to run experiments across different server implementations. The challenge here is that each team may prefer a different technology, and we don't want to couple experimentation to a single use case. We want to be able to be flexible. On the other hand, we do want to shape experimentations in terms of basic analytics and also in terms of the way the experiments are managed, like how to assume an experiment is enabled, how to consume the data about the experiment, and how to influence the service through that experiment definition. So to address this situation, in Python, we built a library for experimentation that defines a protocol interface. This interface specifies the methods and properties a server must provide, but it does not enforce inheritance from any base class. This enables any Python server framework to integrate with the library as long as it fulfills the protocol's contract. Like, for example, we can enforce or pretend the server that wants to run an A/B test will provide a method to get an unleashed client. Or, for example, we can also pretend the server should be providing specific properties such as its name or the metrics client and so on. The result is that we can run experiments consistently across all supported frameworks while giving teams the freedom to choose their preferred server technology. At the same time, we keep the safety of static type checking, ensuring correctness and reliability in every integration, while maintaining the flexibility to be adopted by new frameworks we are not aware of at the time. So long they comply with this protocol interface we define. So most importantly, this approach also gives us a common foundation for experimentation data, regardless of the framework being used. This means we know which basic analytics to expect out of an experiment. Next slide, please. Oh, so there we are. So how do we use this? Well, in order to ensure that a candidate model is good to be released in one of our Python AI services, we can run an experiment, of course. This could be the case in which we want to evaluate a model after a retraining takes place. To do so, we need the service to be running the previously described interface and then start taking advantage of the environment of the different components of the service itself. Broadly speaking, in this diagram, we can identify the distinction between the edge and the inference services. The edge service will receive incoming requests and route them accordingly to the corresponding inference service based on business logic. This architecture enables us the possibility of decoupling the model lifecycle from the general business logic. In this case, this is useful for A/B testing candidate models. In other words, with this architecture, we are able to affect the routing business logic according to the experiment we are running. Then, once we identify KPIs, we are ready to start configuring an experiment. As we are all aware, experiments are defined through unleashed feature flags. We just create a feature flag whose type is experiment and define each of the variants we want to A/B test in the same feature flag. Variants payload follow a specific JSON format that brings the necessary information about the experiment being run. Applications running A/B tests make use of the protocol to extract the information from feature flags, and with this information, they influence how base frameworks route traffic to the target inference services. With an A/B test enabled, the edge service uses the experiment feature flag when deciding how to route each request. After handling the request, the interface we talked about emits standard analytics according to what we consider is best. Next slide, please. So, as an example, we can see the outcome of the analysis of an A/B test. In this particular experiment, we tracked two main KPIs: agent augmentation rate, which is essentially the percentage of messages where the A/B tested service was actually used, and the agent average handle time, which is the average duration of chats. On the right, you can see the results plotted. The group exposed to the experimental treatment increased the agent augmentation rate KPI during time. That gave us confidence that the model evaluated was driving real adoption and engagement in the expected direction. Of course, this is not enough in the sense that we also need to ensure that the overall system behavior looks the same in terms of latency, errors, and why not cost. So along this KPI evaluation, the team carrying out experiment is also taking a close look to the overall system performance when deciding if the model is ready to be released or not.
So Tommy was kind enough to kind of show one of the experiments we've done in kind of our more agent-focused areas of our product. And I wanted to talk a little bit about how we are using it in our generative agent, our flagship product, in a way that kind of harnesses the power of Gen AI while making sure we have the right constraints and that it's learning through our experimentation. So we have a major airline customer who is using our product to handle chat conversations on their website, right? Again, think of you go to the website, you get the little pop-up box, and you start talking to an agent. They wanted their agent very specifically to kind of speak like them and learn from each customer interaction. So in this case, what we did is we used our human in the loop capability, which is a feature that supports humans guiding generative agents while the conversation continues to send a percentage of our agents to live oversight. And the idea here is that there's an agent. So the generative agent is having this conversation with you as a user, and a certain number of those utterances will be sent to an agent who can review it for content, for style, and update the responses. And once the responses are updates, those are sent back to our generative agent and sent on to the customer, right? So this kind of lets us keep the flow conversation going with the user while using the agent's time to very specifically focus on this slice of that interaction. So we record a lot of metadata around how humans are doing this edit, right? We're obviously recording the edits. We're also looking at things like edit rates. We need to be able to control for things like agents who are high quality, agents who are super picky, agents who may just be not giving high quality updates, right? And we want a lot of metadata around the conversation and the agent, right? We want to know what kind of customer came in, what their problem was, what their intent was, to kind of build the best high level like idea of what the context of what that conversation edit was. So the cool thing about that is since we have all that data, we can put it into our data warehouse and use it to fine tune our models in a training pipeline, right? The fine tune unleashes feature flag framework. In this case, helps us deploying those fine tune models in a safe and easy way, right? We get a good balance between automation, where like, for example, we can kind of tool a new A/B tests with a new version of our fine-tune models, but then also have that human approach, right, where a human will decide to activate promote an experiment to a particular environment, manually test, do some sanity checking to make sure that it's within parameters, and then be able to promote that to production. And the cool thing about this is that it's a self-sustaining feature that as we kind of get more feedback and we learn more from the conversations, we can continue to fine tune and improve our models for our customers. And kind of the cool thing about this is we were able to see some direct improvements in the customer's KPIs. So for example, we saw a lower edit rate. That's right, we dropped our edit rate from 30% to 10%, while maintaining having a good customer experience and not impacting the agent's time. They were like, the agents were able to continue with their day-to-day work while also helping us fine tune our generative AI. So the cool thing is we've been able to use our full stack experimentation approach across multiple versions of our system, multiple products and multiple pieces of our system, and we've been able to drive a lot of full stack improvements, such as improving, as we mentioned, allowing agents to oversee responses, being able to safely update foundational models to the latest generation of tools, offering better augmentation rates, and detecting if conversation has ended, all in an attempt to tie that to specific KPIs like fewer mistakes, increased augmentation rate, lower handling time, and improved efficiency. Tommy, do you want to talk?
Yeah, one step back and talking about our infrastructure again. We mentioned feature flags are used in a day-to-day basis by the different services that run the company. Basically, the entire company relies on Unleash feature flags. Since this is a key component at ASAPP, we want to migrate to the newest Unleash version and get to use the latest features available. This is something we're currently working on, starting the process with our cutting-edge services in generative agent. And definitely, we know this is something we're gonna learn while doing, right? So for this to happen, we need to address some challenges we briefly described at the beginning of the presentation. We self-host multiple Unleash instances, one for each of the environments we represent here at ASAPP. And on top of that, there's a lot of integration with Unleash already in place. All of our services, or mostly all of them, are already provisioned to connect directly to those on-prem instances, meaning we can't just switch things over without a careful migration plan. So the main challenge is, how do we move everything to Unleash Cloud while keeping services up and running as expected? Also, while doing this, how can we do better in terms of feature flag management? Is there any feature we can make use of, we can start leveraging? So next slide, please. So, of course, the benefit we see on migrating to Unleash Cloud is finally being able to consolidate all environments into a single cloud instance, instead of juggling with multiple on-prem servers, which also implies some kind of tooling, custom tooling to make the servers behave the way we want to. This simplifies the maintenance and consolidates all the information to where in a single view. I mean, having a single Unleash Cloud instance will allow us to simplify the maintenance, right? Reducing the chance of errors while managing feature flags. Additionally, this also allows us to start taking advantage of projects in cloud and better organize feature flags and get a better sense of how they are doing in terms of technical depth and whatnot. Strictly speaking, this is not new to cloud, but this is something we haven't been leveraging. So why not start doing this after migrating to cloud? So for that, we came up with a migration strategy, which is carried out by a tool developed in-house. The diagram is briefly describing the tool's behavior, in which it takes a backup of the process hosted environment of Unleash, classifies feature flags based on the standard name patterns these follow, transform them into the format expected by Unleash Cloud, and lastly, imports them after validation. All of this is made possible by the Unleash API, which facilitates the automation of tasks such as taking backups, importing, and validating the data. The idea is that once feature flags are migrated to cloud, services can adjust their environment variables and secrets, and ideally connect to Unleash without any issues.
So we really love Unleash, and we're happy to answer any questions you may have. Thank you for coming to our presentation.
Hello, Ivan, and hi, Thomas. Thank you both for this amazing talk. You have such a fascinating domain and very cool use case of feature flags. We have some questions for you in Slido that I'd like to bring to you now. One sec. So do you limit the number of experiments to see the impact on isolation, or do you run a bunch of them together? How do you protect them from the noise?
So right now we are largely our capacity. I think there's like an issue of kind of familiarity and kind of habit with running A/B tests, where like you have to walk, crawl, walk, run. At ASAPP, we're largely we have kind of more of a capacity issue. So right now we are running a limited number of experiments per customer, just to avoid kind of multi-arm bad and second order effects. In past lives, at my last job, we did a lot of A/B testing, and in that case, that we did run the heavy risk that you would have A/B tests kind of stepping on each other, and the way we managed that was around there was a lot of work kind of turning the experimentation process from a technical task into kind of this full stack effort where like product and design are involved upfront, and that meant standardizing things like what are the things we can A/B test in parallel? How do we get the KPIs and metrics tied to each one so that teams can kind of self-serve their experimentation without accidentally stepping on each other or interrupting interrupting each other's tests. This is obviously an easier problem when you are a smaller startup than when you are a larger company, and that's something we're looking forward to navigate as we do more of this testing in the generative AI space.
Oh, thank you. And I think there's another one. Let me mark this as answered, and there's another one for you. Where did it go? There. I think this is specifically for you, Ivan. Like, how did you get involved with being the maintainer?
Really, honestly, I had wanted to learn Python. I was a test automation engineer at the time, and I had wanted to teach myself something new. So I thought there was another Python SDK, an open source community version that wasn't fully featured. So I thought like, hey, let's give it a try. And I worked really closely with Ivar and the folks at Unleash. At that point, I think Ivar was still working for, I forget the name of it. He still had a day job. But I think like it was really easy. They're a great team. They work really well with open source. And I think they are the documentation and I think kind of the scenario testing they do, they make it really easy to kind of learn and contribute to open source packages that integrate with Unleash. So big shout out to the team for that.
I think that must have been back in 2016 or something. It was the early days of Unleash.
Yeah, it was very early in those days.
Yeah.
Yeah, thank you both for being such long-time users and contributors. I know firsthand from our engineering teams that they love collaborating with you, and you're basically famous at Unleash, Ivan. So thank you for good reasons. All right, yeah, so one of my jobs, unfortunately, is that I have to keep us on schedule. So I'd like to now stop sharing and bring on the next speaker. Thank you both for sharing your insights and experience, and see you soon.